Good morning, chemistry students. This is Mrs. Pugh working on the rules for significant figures. And significant figures is just another way of indicating numbers that are measured. So in math class, we might say, for example, that 5 is the same as 5.0. But in science class, the 0 is showing that it is measured down to the tens place, making it what we would consider a measured number. So numerically, 5 and 5.0 are the same, but in terms of a measurement, it's showing how specific the measurement is. So there are a few rules that help us to determine which rules in a measurement are measured. And the first rule is that all non-zero numbers are considered to be measured. And so in the number 1,781, there are actually 4 significant figures, or 4 sig figs, or 4 measured numbers. In the number 37.5, that would have a 3, a 7, and a 5. All 3 of those would be considered to be measured, so that one would have 3 significant figures. Now, when you see the number in scientific notation, like 5.342 times 10 to the 4th, the times 10 to the 4th is showing how large the number is. So we don't include that as part of the sig figs, but what we do include is the 5, the 3, the 4, and the 2, so that one would also have 4 significant figures. Okay. Rule number 2, captive, or some teachers refer to it as sandwiched zeros, which is zeros between non-zero numbers, are considered significant or measured. So in the number 102, you would have the number 1 is considered measured. The 0 is considered measured because it's between the 1 and the 2, and the 2 would be measured. So that number would actually have 3 significant figures. In the number 3.00507, the 3 would be considered significant. The 0, the 5, the 0, and the 7 would all be considered to be measured. So that number would have 6 significant figures. All of those are considered measured numbers. In the number 5, 50.01, the 5, the 0, and the 1 are all considered to be measured. So those ones would have 4 significant figures. So, rule number 3, leftmost zeros, sometimes referred to as leading zeros, that are in front of the first non-zero digits are not considered significant. And remember, that doesn't mean they're not important. It just means that they're not measured, and maybe they were converted from one unit to another. For example, maybe the 47 was in nanometers, and then it was converted to meters. And so all of the zeros that are after the decimal but before the first non-zero number are not considered to be measured. So that means that this 0 is not measured, and all of the ones before the first non-zero number are not considered to be measured. So none of these are counting as measured numbers, and the 4 and the 7 are. So this one would have a total of 2 significant figures. This 0 would not be measured, so we would say that the 5, the 8, the 4, the 7, and the 2 are measured, so that would be a total of 5 significant figures. In this number, the 0, 0, 0 are not measured, but the 3, the 4, and the 5 are considered to be measured, so that one would have 3 significant figures that were measured in this problem. All right, rule number 4, zeros at the end of a number, and here's the important term for this, and to the right of a decimal point are significant. So in the number 43.00, it's showing that that measurement was taken down to the hundredths place. So the 4, the 3, the 0, and the 0 are significant. Looking on to the next one, in 1.010, all of those digits are considered to be measured, and so you would have the 1, the 0, and the 0 here are all considered measured, so that one would have 4 significant figures. Looking for a better pen here. In the number 90.000, all of these numbers would be considered to be measured. So it's going down to the thousandths place, showing how specific the measurement is. So that would be 5 sig figs. Now, here this 0 is before the first non-zero number. Going back to rule number 3, that makes that 0 not significant. It makes this 0 not significant. The 1, because it's a non-zero number, is significant, and the 0 that's after that is also considered to be significant. So in this number, there are 2 sig figs. And finally, in the last number here, this first 0 before the non-zero numbers are considered significant. The 8, the 7, the 0, and the 0 are all significant, so that one would have 4 sig figs, or 4 measured numbers. All right, hold on, we're getting close to being done here. Rule number 5. Zeros to the right of a number that does not, and this is a key part to this, that does not have a decimal point are not considered to be measured. So if it does not have a decimal point, then this 0, this 0, this 0, this 0, and this 0 are not considered measured. It's just showing how large the number is. So in this case, 300,000 kilometers is considered to have 1 significant figure. Now, here's a what if that often students will ask. Wonder if this number was 300,000.0. Then, of course, it has a decimal and it would count, and we'll talk about that in just a minute. In the number 7,000 meters, this 7 would count as measured, but these would not count as measured, so they would not be considered significant. So you guessed it, 7,000 would have 1 significant figure. Next measurement, the 2, the 7, the 2, the 1 would be measured. This one is just showing how large the number is, so it is not significant, so it would be considered to have 4 sig figs. And 550 mils, this 0 would not be considered to be measured, and so it would have 2 significant figures. Now, as I had mentioned a minute ago, let's talk about the what ifs. If the number is 300, use my funky writing on the screen. If the number is 300, then it would have a total of 1 sig fig because of Rule 5. But if the number is 300.0, the only reason that 0 would be on there is if the measurement scale was down to a tenths place. So this all of a sudden makes these zeros significant because of the previous rule. So this number would actually have 4 significant figures. The 3 and all of the zeros are considered significant. Okay, here we go. Exact numbers. Exact numbers are considered to have an unlimited number of significant figures. So what does that mean? That means when you're counting things where you can only have an exact number, then you're not going to limit your calculations based on that counting number. What's a counting number? That would be things like 5 students. You can't have 5.1 students. What would that be? Like a student in one hand? So it would be considered to be unlimited number of significant figures. Same thing with 3 paper clips and 10 books. All of those would have unlimited numbers of significant figures. Exactly defined quantities. would also not limit how many sig figs you could have in your answer. So something like 100 centimeters equals 1 meter does not limit the number of significant figures in a problem, so it is considered to have unlimited numbers of significant figures. In other words, it's exactly 100.000000000 going on forever equals exactly 1.000000000 meters going on forever. So you would not limit your problem according to exactly defined quantities. All right, thank you very much.